Hi, today we are going to see the Management Information System. I'm Roob Lakshmi from SAC College of Kambam, and today we are going to cover the topic is System Analysis and Design, Components of SAD, System Development Life Cycle, that means SDLC. Let's start the topic. System Analysis and Design. To learn new approaches and different techniques for building the organizational system. It improves a basic understanding of system characteristics, system design, and its development process. System analysis. It is a process of collecting and interpreting facts, identifying the problems, and decomposition of a system into its components. System analysis is conducted for the purpose of studying a system or its parts in order to identify its objectives. Next is system design. It is a process of planning a new business system or replacing an existing system by defining its components. Before planning, you need to understand the old system thoroughly. What is a and few points about the system design is system design focuses on how to accomplish the objectives of the system, and main focus on is systems, processes, and technology. What is a system? A system is an orderly grouping of interdependent components linked together according to a plan to achieve a specific goal. The few elements of the system is control, processor, output, feedback, and inputs. Let's see the topics. Outputs and inputs. The main aim of a system is to produce an output which is useful for its users. Inputs are the information that enters into the system of processing. Processor. The processor is the element of a system that involves the actual transformation of input and outputs. It is the operational components of a system. Processor may modify the input either totally or partially depending on the output specification. Next one is control. The control elements guides the system. It controls the patterns of activities governing input, processing, and output. In order to keep system in balance, what and how much input is needed in determining by output specification. Next heading is feedback. The feedback provides the control in a dynamic system. Positive feedback is routine in nature that encourages the performance of the system. Negative feedback is informational in nature that provides the controller with information for action. Next, we are going to see is types of system. In types of system, there are physical and abstract system. In physical, we can touch and feel them. Physical system may be static or dynamic in nature. For example, static systems are desks and chairs or the physically parts of computer. Dynamic system is a programmed computer in which programs, data and application can change according to the user's needs. Abstract system or non-physical entities or conceptual that may be formulas, representation or model of a real system. Open or closed systems. And open system must interact with its environment. It receives inputs from and delivers output to the outside of the system. For example, an information system which must adapt to the changing environmental conditions. A closed system does not interact with its environment. It is isolated from environmental influences. A completely closed system is rare in reality. Adaptive and non-adaptive system. Adaptive system responds to the change in the environment in a way to improve their performance and to survive. For example, human beings and animals. Non-adaptive system is the system which does not respond to the environment. For example, machines. Next topic is permanent or temporary systems. In permanent systems proceeds for long time. For example, business policies. Temporary systems is made for specific time and after that they are demolished. For examples, ADJ systems is set up for a program and it is disassembled after the program. Naturally and manufactured systems. Nature systems are created by the nature, for example, solar system and seasonal systems. Manufactured systems is the man-made system, for example, rocks, dams and trains. Next topics next topic is components of SAD. In this we are going to under this components of SAD we are going to see 5 topics. They are organization, interaction, interdependence, central objective and integration. Under the organization implies structure and orders. It is the arrangements of components that helps to achieve certain objectives. For example, in a business system, the hierarchical responsibilities starting with the managing directors on top and leading downward to the workers represent the organization structure. Similarly, computer system is designed around an input device, a central processing unit, and output device and one or more storage units. When linked together, they work as a whole system for producing information. Interactions. Interactions refers to the manner in which each component functions with other components of the system. In a business system, for example, purchasing must interact with production, advertising with sales, and payroll with personnel. In a computer system, the central processing unit must interact with input devices to solve a problem. In an education system, a teacher interacts with a student to disseminate knowledge or ideas of a particular subject. Next topic is interdependence. Interdependence means the parts of the organization or computer system depends upon each other. They are coordinately and linked together according to a plan. For example, in an education system, a student is dependent on teachers to guide him or her favorable and positively. In addition, the computer of one subsystem may act as an input to another subsystem. Integrated. Integrated refers to the holism of system and is concerned with how a system is tied together. It is more than sharing a physical part or location. It means that the part of system work together within the system even though every part performs a unique function. Successfully integrated with typical procedure, a greater, clearer, and total impact that each components work separately. Next topic is central objectives. The last characteristic of a system is its central objectives. Objectives may be real or stated. Although stated objectives may be the real objectives, it is not uncommon of an organization to state one object and operate to achieve another. The user should be aware of the central objectives of a computer application early in the analysis for a successful design and conversation. The analyst must work around such obstacles to identify the real objectives of the proposed change. Next, we are going to see system development life cycle. In this, SDLC is a process used by a software industry to design, develop the test high quality software. SDL is a process followed by a software project within a software organization. The life cycle defines a methodology for improving the quality of a software and the overall development process. There are few stages of SDL. The stages of a typical SDL are planning, defining, designing, building, testing, and development. Let's see the stages. In stage 1, planning and requirement analysis. Requirement analysis is the most important and fundamental stage in SDL. It is performed by the senior member of the team with input from the customer, the sales department, market survivors, and domain experts in the industry. This information is then used to plan the basic project approach and to conduct product feasibility study in the economical, operations and technical areas. Planning for the quality assured requirements and identify of the risk associated with the project is also done in the planning stage. The outcome of the technical feasibility study is to define the various technical approaches that can be followed to implement the project successfully with minimum risks. Stage 2 are defining requirements. Once the requirement analysis is done, the next step is to clearly define and document the product requirements and get them approved from the customer or the market analyst. This is done through an SRS. SRS means Software Requirement Specification. Documents which consist of all the product requirements to be designed and developed during the project life cycle. Next, the stage 3 is designing the product architecture. SRS is the reference for product architecture to come out with the best architectures for the product to be developed based on the requirements specific in SRS. Usually more than one design approach for the product architecture is processed and documented in a DSS, means design document specification. This DSS is reviewed by all the important stakeholders and based on various parameters as risk assessment, product robustness, design modularity, budget and time constraints. The design the best design approach is selected for the products. And a design approach clearly defines all the architectural models of the product along with its communication and data flow represented with the external and third party module. The internal design of the of the processed architecture should be clearly defined with the mm, minimist of the details in DSS. And next stage 4 is building or developing the products. In this stage of SDL, the actual development starts and the product is built. The programming code is generated as per DDS during this stage. If the design is performed in a detailed and organized manner, code generation can be accomplished without much hassle. Developers must follow the coding guidelines defined by their organization, and programming tools like compiler, interpreters, debuggers, etc. are used to generate the code. Different high-level programming languages such as C, C++, Pascal, Java, and PHP are used for coding. The programming language is shown with respect the type of software being developed. And next is stage 5. In this, the testing the product. This stage is usually a subset of all the stages as in the modern SDL models. The testing activities are mostly involved in all the stages of SDLC. However, this stage refers to the testing only stage of the product where products defects and reported, tracked, fixed and retested until the products reaches the quality standards defining in the SRS. Next one is stage 6, development in the market and maintenance. Once the product is tested and ready to be developed, it is released formally in the approximate market. Sometimes product development happens in stage as per the business strategy of that organization. The product may first be released in a limited segments and tested in the real business environment UAT, user acceptance testing. Then, based on the feedback, the product may be released as it is or with suggested enhancements in the targeting market segment. After the product is released in the market, it maintenance is done for the existing customer basis. And next is software development life cycle models. In this we are going to see few models. They are waterfall model, interact model, spiral model, V model and Big Bang model. In first one we are going to see is waterfall model. Waterfall model is the simplest model of software developing paradigm. It says that all the spaces of SDLC will function one after another in linear manner. That is, when the first phases is finished, then only the second phase will start and so on. Like the I am showing the picture waterfall model. Requirement gathering finished, after that only system analysis, after that only coding and testing and implementation and operations and maintenance. Next is interactive model. In this interactive model leads the software development process in interaction. It projects the process of development in cyclic manner, repeating every step after every cycle of SDLC is processed. means the software is first developed on very small scale and all the steps are followed which are taken into consideration. Then on every next interaction, more features and modules are designed, coded, tested and added to the software. Every cycle produced a software which is complete in itself and has more features and capabilities than that of the previous one. After each interaction, the management team can do work on risk management and prepare for the next interaction because a cycle includes small proportion of whole software process. It is easier to manage the development process by it consumes more resources. And next one is spiral model. In the spiral model, we can see a combination of both interactive model and one of the SDLC model. It can be seen as if you choose one SDLC model and combine it with cyclic process interactive model. This model consider risk which often goes unnoticed by most other models. The model starts with determining objectives and concentration constraints of the software at the start of one interaction. Next phases is of prototyping of the software that includes risk analysis. Then one standard SDLC model is used to build the software. In the fourth phase of the plan of next iteration interaction is prepared. And next one is V model. In this V model, the major drawback of waterfall model is we move to the next stage only when the previous one is finished and there was no change to go back if something is found wrong in lateral stage. V model provides meanings of testing of software at each stage is reverse manner. At every stage, test plans and cases are created to verify and validate the product according to the requirements of that stage. For example, it requirements gathering stage, the test team prepares all the test the test team prepares all the test cases in correspondence to the requirements. Later, when the product is developed and is ready for testing, test cases of this stage verify the software against its validity towards requirements at this stage. This makes both verification and validation go in parallel. This model is also known as a verification and validation model. And next one is Big Bang model. In this model, the simplicity model in its form, it requires little planning, lots of funds, and lots of programming. This model is con- conceptualized around the Big Bang of universe. All scientists say that after Big Bang lots of galaxies, planets and stars involved just as an event. Likewise, it we if we put together lots of lots of programming and funds, you may achieve the best software product. For this model, very small amount of planning is required. It does not follow any process or at time. The customer is not sure about the requirements and further needs, so the input requirements are arbitrary. This model is not suitable for large software projects but good one for learning and experimenting. Thank you for listening this video.